welcome back to the channel where we are building a video game from scratch using Love2d and Lua. My work didn't get out till 7:30 tonight, so that's why I am a little late streaming. But I think what I want to do today is start to work on getting our spellcast entities colliding with our enemies, because then we can kind of knock them back so that we can have some interaction, because right now the the bad guys just kind of go all over our face like this right now, but we want our game to be more interactive, so we're gonna see if we can figure out how to do that today. So I've only got about an hour to stream because I've got homework, but we're gonna see if we can get some stuff done here. So what we need to do, we need to either add a function to our entities, and let me think, either to our spellcast entity or to our bad guy entities. Now, I guess, we have to check for collision on every of our spellcast entities with every of our bad guy entities, because we need to check for those collisions. So I guess it doesn't really matter too much which function we put that on. We could do a spellcast collides or a entity collides. And then, the parameters that we put in, if we do it on spellcast collides, then we would have a parameter of entity, and then if we do it on entity, we'd have a parameter of a spellcast. So it's totally up to us. I'm trying to think of a reason not to just go ahead and do it on the spellcast entities. I don't know why I wouldn't, but I kind of want to, take a couple seconds to think it through before I commit to it. Like what might be an issue with putting it on our spellcast entities? I'm not exactly sure. And you know what? We don't even have... I don't know if we even have a spellcast. I thought we had a spellcast entity class, but maybe not. Let me see in our scene. So these spellcast entities are populated with literally just an entity. So it's okay. So that answers the question for us. We need to write just a function for our entity that takes in another entity that checks for a collision, and then we'll have to also be able to update our enemies by a delta X and delta Y, which at the moment I don't believe we have. Let me see, does our entity class even have a dx and dy? It doesn't. So I think we need to add this, because we need to be able to knock back our gecko once we collide with it, right? So it needs a change in x and a change in y. So I'm wondering if, and this would probably be in the, not in the entity class, but in the state that the entity would be in. So probably the walk state for our entity. And I don't know if we want to get so deep that we're having another state machine for if a gecko is hit, because it would have to do a couple different things. It would need to flash red, it would need to inherit a dx and dy, and then it would need to ultimately stop flashing. Yeah, it kind of feels like to me we kind of do need another state, and we can change from the walk state to a recently hit state, which will control its rendering as well as its dx and dy, and then we would need a way to once it's done being hit, to go back into the walk state, and the walk state is what has its AI seeking behavior. So I think for now I want to add to our ND class a DX and a DY. We'll instantiate them to 0. But we want to ultimately, at the end of our update function for our entity class, we'd want to see, and we're doing it, we're updating our state machine, but we also want to, regardless of state machine, I think we want to update our X position to be its current X position plus its change in X. And then we want our Y position to be updated by its delta Y. And then this will allow us to just test now, one thing we want to do, like let's say we give it a dx and dy of say like 2 or something, it would be, if we just give it the dx and dy of 2, it would then have a dx and dy of 2, and it would draw it more to the right and more down and more to the right because of the 2, and it would get a diagonal movement like that over time, and it would never stop. So we need to decrease our dx and dy over time so it gets back to 0, so that we're not shifting, so that our dx stops becoming a positive number, you know? So like what we could do, because I think for right now, we're updating our x and y position based on our dx and dy, regardless of what state we're in. So I think if I were to change this to be like a 1, then I think even our player and maybe even our spellcast entities would start being rendered all wrong. So let's just see, because I think, yeah. So even see, it's for all of our entities. So it's almost like we only want to do that. We only want to do that if it's if it's hit or whatever. So maybe we can do that like we have a hit field called false. We are giving it a dx and dy of 1, but we only want to update its x and y position if we're actually hit. So we can go ahead and try that. And then what we need to do is, we're not becoming hit, so we're not updating based on dx and dy. So now we need to manually change our gecko's entity status, field status, to be equal to true, so that it would update with this 1 dx dy. And then we'll continue doing stuff. So let's see. We need to go to where we instantiate our entity, which is right here. And we can go ahead, this is actually that's just our spellcast entity. We need our gecko. So what we can search for gecko right here. So we give ourselves 1 gecko entity, and then what we need to do is go to the map that we're at, in the entities table that we're at the index of this entity, and we need to modify its .hit to be true. So now only the gecko should be getting that downwards and rightwards motion if we did this right. Nice. And then the particles go with it. Okay. So and that's such a big number because he moves so fast, even though the dx and dy is 1, for 2 reasons. One, because it's 60 frames a second, so it's getting 60 times a second, you know. And then 2, our Game Boy resolution is so tiny, it's only 200 pixels wide, so in the course of 3 seconds, that's the whole screen. So what we could do is make our dy much slower. Something like maybe 0.2 or something. Like we want to find like a decent speed to be hit and knocked back. So, that's interesting. Now we got we get this weird pixely. I wonder if we're flooring. Oh, that looks so bad. It's because I know why. It's because we're rendering such a tiny resolution that when it's trying to render, and you know what? I thought that this wouldn't happen. I thought that since we came up with this issue when we were trying to walk ourselves diagonally, and the answer was we just had to floor it to the nearest, at least on the render, we floor it to the nearest X or Y position. So maybe we're just not flooring our position when we go to render. Yeah, so maybe we can just put a math.floor in our render here, and that might tidy it up a bit. See though. Yeah, and then we need it here as well. Okay, and then math.floor. Now I know there's a better way to do this, but let's see. Whoa. Okay. So it didn't okay, this is the wrong place to do it. We're actually flooring the X and Y position. We don't want to do that. We only want to floor the render. Now this is in the render, but that is my bad. I don't know why we put that here. Because it was flooring it, therefore we were never moving, because every frame we were only 0.1 pixel, and then we were flooring it, and then we were getting that new 0.1 pixel, and then we were flooring it. So we need to draw this. We need to floor this. No, that's just for our particle system. So we actually need to go. We probably need to floor that also. Let me see if the particle system looks weird. Yeah, well, no, actually particle system kind of looks fine. Let me just see. I don't think it could hurt to floor this. At argument 1, number expected. Okay, well, I don't know why that is happening. What did we change? What did we change? Unexpected symbol. Okay. What is going on? We can't floor this? What? I don't know, maybe it's not instantiated as an entity by the time our entity is ready? No, we've got an entity right here. I guess it's only got a particle system if it's a type gecko, so maybe we can... Let me just see if we can say if self.type is gecko, and then see if that will floor it, because I don't know why this would happen. So like that works, and then we try to floor this. Okay, so it is because not all of our entities have a particle system, so when I try to floor an adjacent offset x, or actually it's a bad argument 1, so it's the particle system that was crashing. Okay, well, now let's go, and ideally this isn't gecko, ideally this is just if has particle system, like. I'm going to leave a to-do in here so that we can grep search to-do at some point and come back and fix this, but we're trying to floor the value of our render for our state machine here. So we need to go to both to our idle state, and I think we need to floor it here. Math.floor. Let's see if this gives us a smoother pixels. Let's see. Yes. So see, like it does, it goes but 1 pixel at a time, but at least now it's not trying to interpolate those pixels in between, those 0.1 of pixels over time. So that at least makes it, you know, because it was trying to draw it at every 0.1 of a pixel, and that's why it was doing that. Let's see it again. So without the floor, it looks like that, because it's trying to interpolate what the pixels would look like in between those values. But now we just floor it so that it'll. And we're not updating, we're not flooring the actual position, we're just flooring where we're rendering it. So there is a better way we could do this. We can ask, you know, if the X position is closer to be rounded up or closer to be rounded down, and then do that appropriately. And that could cut out on some of the jitteriness. I don't know if we want to do that. But I think that's out of laziness, not out of, because that we probably should do that. I'm curious, because it would look better, because it would mean instead of flooring it every 10 frames, it would floor it every 5 frames and then seal it every 5 frames. But then I guess that would still result in the same amount of pixels per second that it changes, because there's still, yeah, it would just change which pixels we round, but overall we would still be rounding 10 pixels per, or 10 frames out of the 60 frames. I think we wouldn't need to do that. Yeah, I think the output would be the same. We should probably try that though, but me thinking through it makes it sound like we don't need to do it. So now that we've got a dx and dy for our entity, it doesn't look quite like the speed we want our hit to be. So if we hit it with a spell, we'd want it to back up a lot like that, but maybe I want to say like twice as fast, but this dx and dy needs to go back to 0 once we hit it. So it needs like a faster initial velocity, and we slow it down over time once he's hit. So I feel like it still needs to be a bit faster. And the faster it is, the smoother that 1 pixel looks. I think something like that, but it has to slow down. So let's slow it down over the update function and make sure we do it right in our update, and we can say if our dx does not equal 0, I guess we could say is greater than 0, then we want to decrease our dx by a certain amount. So like, let's say we decrease it by 0.1. Let's just try that. But if our dx is greater than 0, then we want to set our dx to be equal to and how do we do this? Because we want to put the current dx minus our decrease, because we want to decrease it. But we don't want to go lower than 0, so we want to say that this is actually a math.max, which will return the greater of two values, one of which is 0. So we're either going to decrease our dx by the decrease speed, or we're going to return 0. Because we want our dx to be set, our dx and our dy to be set to 0 if we've decreased to the point of stopping, at least on the velocity. If that makes any sense. So we can do this too. We can say for our dy, if our dy is greater than 0, then we're going to go ahead and update our dy, and we can say, we can either add this local variable up outside of our function, so we don't have to declare it twice like this, but for right now, let me just see. Self.dy is going to get its current dy minus this decrease, and actually, yeah. This is actually, this isn't so great, because depending on which direction we were knocked, our dx and dy might have to increase. So we don't want to clamp this to 0. But okay, I think I got an idea. So like, if dx is greater than 0, that means we were knocked to the right. So if we were knocked to the right, we're going to slowly decrease our change in x until we've stopped. The other, if we get knocked to the left, our dx would be smaller than 0, not equal to. So since we're doing equal to and not, or smaller than instead of equal to, we should be able to account for each direction of being knocked. So we just have to do it for each direction. So instead of, we could probably keep this decrease variable, but I want this local to our entity update, so we don't have to do it every time now that we have to do it 4 times. So if our dy is greater than 0, that means we're getting knocked down. So we're going to update our dy to be itself subtracted by decrease until it's 0. So it's the same idea here. We want a math.max 0, or this change in our delta y. Then we can do our other cases, which is if our self.dx is smaller than 0. Hey Warren, how's it going, dude? It is going okay so far. We're working on getting the our character, our bad guy, to be knocked back. We're working on getting our character being knocked back by our spellcast. So right now we've got him being moved, but we need to slow down the movement so it would stop, so that it gets updated, gets hit, and then it stops, and then it goes and follows us again. Hey, what's up, K-Tronics? Good to see you, dude. How's it going? Yeah, so no, I didn't end up adding any of that just yet. I was just kind of messing around, testing some new stuff. I haven't figured a way to get like looping working on stream here, so that I can kind of record like a bass line and then play around with some melodies. But it's a little tricky when I'm streaming, because I normally use OBS to record my screen and stuff like that, but I can't do that when I'm streaming on Twitch. So I'll have to figure another workaround to record my computer sounds while I'm streaming, so that we can do that on stream. But I have not figured that out yet. So this would be the getting knocked left, because our dx would be negative. And what we'd want to do is update our dx to be our current dx plus our decrease, which sounds ridiculous, but we're adding our decrease instead of subtracting it, so that we would move us more and more to the right until we are stopped. Now, I guess Yeah. I guess I don't know how to stop moving us, because we would, what is the max value we need to clamp this to? Okay, we would do a math.min with a 0 in there as well, because we'd want to stop at 0, so we stop moving us to the right. So we would say math.min, and we give it 2 arguments. One's a 0, and one is a self.x dx plus our decrease, which is a little confusing, but it makes sense if you think about it. We're adding the decrease, which is going to move us to the right, and we want to stop moving us to the right if our dx is equal to 0, or actually is, if our dx ever becomes greater than 0, this math.min will return 0. That'll set our dx equal to 0, and that would stop updating our dx and dy, because it'd be set equal to 0. So we just have one more case to do, and it's if our self.dy is smaller than 0. So that would be getting knocked upwards. And if we're getting knocked upwards, we're going to slowly decrease our delta y so that it is actually, and by decreasing it, we're moving it upwards. Let me think this, yeah. If our dy is negative, that means we're moving upwards. So we want to add our decrease until we hit 0, just like this other one. So we would add our decrease, make our number bigger until we hit 0. And then we want to make sure that this is a math.min, because we want, is that right? Because we want the smaller of 2 values. Well, let's see. If we get knocked upwards, it would be a negative number. So yeah, math.min would clamp it to 0. It'd be either a negative number, slowly getting less negative, until once it becomes a positive number, this would return 0. So I think that's right. And then the fact that these are all less than or equal to, and not less than or they're either less than or greater than, which means will only be equal to 0 by the time one of these things finishes. So let's see, and I think we want our decrease to be much smaller. Let's see if we decrease to be like 0.03 or something. Let's see, ideally we want our entity to be like moving fast and then slow down, and then ultimately stop. So let's see if that's working. Yeah. See how he kind of skid? He kind of skid there, and we can make it, take longer to stop by decreasing our decrease. Yeah. And then we can also give him a faster initial velocity up here with our instantiation of dx and dy. Maybe let's just see, because I just want to see what 1 might look like, because we slow it down so fast. Let's see what a dx and dy of 1 looks like. Yeah, wow. That's really cool. And then he goes to tracking mode. So I think ultimately we do want to move this into a separate state machine. We want to increase this by maybe point whatever. Let's see. Yeah, a little less. We want him to get knocked back. Yeah, that looks about good. That looks about good in my mind, but we can always change it. So now the difference is this is Yo Warren, I'm a beginner, so if you've got something that is much, if you got a good idea, I'm open to hearing it. There's sometimes when I'm like kind of in the zone that I don't want to be trying to read other people's code, because Twitch like takes out the spaces, right? So like when I'm looking at people's idea and people explain code in different ways, I'll look at it and be like, I know that makes sense to you, but it's not making sense to me. So it can be a hit or miss, because it's so hard to describe code to people. But I don't know what I'm doing, so if you've got a better idea, I'm totally open to hearing it. I just get what can work, not like the best way to do it. It's just like, oh, this is a way to do it, and then I just keep moving on. So ideally we only do this dx update if our entities actually hit, right? Because we don't want to knock them back. But then again, we need to change the direction of the knockback based on how it gets hit. So what that might look like is like we would instantiate these dx and dy to 0, but then once the function that we wrote, the entity collides with entity, once we're done with that, we have to decide which quadrant we want him to get knocked into. And then if we were to, for example, want him to go down into the left, we'd put in a negative dx and a positive dy. That should get him going down into the left. And then if we want him down into or left and up, we'd give it a negative dy, negative dx, just like this. And then if we want him to go up and to the right, we would give it this. So we would set the dx based upon whatever quadrant he kind of gets hit, I guess. Frame rates. You might want to do multiple. You decrease by the frame time. I'm guessing that's what dt parameter is and the update function is. You might want to multiply. See, yeah, I'm just not sure what you're saying here. Like, is it because delta time can be different per frame? Is that what you're saying? It's just so hard to, it's really hard to parse what people are saying over code, because everyone has a different way of saying it. So are you saying we need to multiply by delta time instead of adding? So we scale by the difference of delta time? Is that what you're saying? So we would just, I guess we would just multiply by delta time over here, and then we'd have to change all of our variables to kind of be 3 times bigger so that it would be, but this would give us a consistent speed over time, or yeah, no matter how many frame rate a second is, it would kind of update this the same. So I think since delta time turns out to be, crap, yeah, we would need to multiply these things by like 60, I guess, in order to get the same values. Yeah, it's so tiny. So let me just see if we, no, we want to multiply it. Let me just see if multiplying it by 60, because delta time is time elapsed since last frame, so it's like about 60 times to get us back to the original speeds. I think, I mean, I could be totally jacking this up. Yeah, maybe just decrease value times delta time. Crap. I don't know. Maybe this has to be inside our parentheses here. This is, I did just watch a video about this sort of stuff, and I thought, you know, I'm beginning to understand it, but it's hard to internalize it because I've never done the, I guess that, oh god, I guess that makes sense why they use delta time, so that you can have it frame rate independent. Let's see. He did stop moving, right? Let me see if this is like 0.05. I guess our decrease just needs to grow. That's looking about where we were, maybe higher initial velocity. Yeah, that's looking about right. So, yeah. No, I appreciate it, Warriana, because that's something I need to start thinking about, because I don't really have control over, like Love2d will spit, it'll try to get you 60 frames a second, which we're actually printing up the frames per second down there, but it's not guaranteed. So like when I was on Linux and I was streaming and doing this, we would hit like 48 or so, but that would mean that our speed and stuff is variable based on the frame rate, where we want it to be independent of the frame rate, so that it would play normal, it would play the same rather at the different speeds, which is something we need to do for the rest of our game, honestly, because we haven't been scaling by delta time for our player movement or for our spellcast entity update or anything like that. So that's something we need to add globally to our game, but that is a good thing to think about, and it's something that, you know, I probably should be worried about, because it affects gameplay. If someone's on a machine and can only get 30 frames a second, we don't want it running. Would that run everything half speed? Yeah, it would run it half speed as opposed to the same speed we want. So I think you're absolutely right that we need to do that sort of stuff. I'm gonna add to our notes that we have to do that for our other things. We've got to do add frame. Because right now, we're doing that only for our delta X and delta Y for our entity class, but we're not doing that for our typical X position updates for our entity. So we've got to start adding that all around. Okay, well, we're doing pretty good. We've got a knockback for our entity class. Now we still need to have the collision detection function, and we actually have a entity collides with target, AABB collision function here. So we could already potentially test collision for our entities. Let's see. We can either run every frame in our entity update checking for collision of any of our spellcast entities, or we can run every spellcast entity update checking our entity, our bad guy entity. I feel like we want to check our bad guy for every spellcast entity, but I don't know why I feel like that. Yeah, we want to do... Now let's see where our spellcast entities live, and they live in the scene. They live in the scene as a spellcast entities table. So since we only have one spellcast entity count, we should probably have this based on this number so that we can also cycle through an appropriate amount of things. So spellcast entity count gets 1, and then we can do this at self.spellcast entity count, and then just make sure we're rendering our entities still. Yeah, for our spellcast. This is getting there, guys. This is getting there. Okay, let's see if we can get collision detection for the entity here. So now that we've got, one thing I don't like is that our scene view, which is the instantiation of our current scene, is still global, but I don't know how to make it local, because we need to pass it to everything. I mean, we could make it local and pass it to every little instantiation and everything. But I feel like then we have to update its. I don't know if it's more trouble than it's worth. We're making a Game Boy game. I don't know how absolutely necessary staying away from global variables is. And we still haven't updated a lot of our game to be local, so I don't know. I've never made something this big, so I guess we'll find out if it becomes an issue. Let's go. So we've got our spellcast entities in our scene. So we need to go into our entity and go into the update. And actually, yeah, we only want to do this if it's a type of entity that can be hit by our spellcast. So I don't like that we're doing the if type gecko, because we want to do it for any type, but we don't have. I guess for right now we'll put it as we check. We only want to check our entity's collision with a spellcast entity if it's an enemy, right? So like we would, I guess, let's say if our entity itself collides with a target, and the target is, and we need to go through our scene view at our spellcast entities, spellcast entities at index of whatever, because we need to do this a for loop amount of times for I gets 1, for as many as our scene view dot spellcast entity count, spellcast entity count, is that what we called it, in fact? Spellcast entity count from our scene. So our scene is the scene view. Where are we here? Scene view dot spellcast entity count, yes. Do, and then we're gonna check the collision, and it's gonna say if our entity collides with a spellcast entity, then, and for right now, if what am I doing? Cache. Then, okay, then we would give it. Now, for right now, we know we want dx and dy to be about 0.5, but we only want it to be about 0.5 if we've actually been hit by a spellcast entity, and we don't know exactly what direction we want just yet. We can figure that out in this function, but for right now, I'm just going to say that we get 0.5 and 0.5, which would give us a rightwards movement and a downwards movement. And then we would become self.hit gets true. Now self.hit gets true would actually update our x and y position to be our change in x and y position. And then, since these values are not 0, they will slowly decrease over time, slowly stopping us. But then once we're 0, we need to flatten out if our dx and dy. I don't know when we should do this. Like we need to set our self.hit back to false at some point, and I guess once we stop. So like if self.hit, maybe we can say in here if our dx is equal to 0, not assigned to 0, and it's or our dy. If either of these two things are true, if either of them are equal to 0, then we're going to want to go ahead and become self.hit no longer. And then if we did our collision function correctly for our AABB, and if we're passing our entities through as entities themselves, which I think we're doing that right, we might be in business. But let's see. Oh, shit. We're moving. Oh, shit. Okay, so I've got a couple of notes. We only want to do this for our enemy objects. So for right now, we're going to say if type is equal to gecko. This is actually if it is an enemy, then we'd go and check it. We'll have to add that, but that should stop our player from moving. Great. And then the other thing is, our spellcast entities are actually always circling around us because we wanted to have some continuity for the spellcast, even if you couldn't see what you were casting. So our spellcast entities are actually around us, circling at all times, whether or not you could see it or not. So we're not checking if it's a successful spellcast and the collision detection. So let's see where our successful spellcast is. Successful spellcast is part... Oh, see, this is bad. Well, we are a global... I don't like this, but we have our successful cast in our play state. So we either need to pass this variable, this local variable, into each of our... pass it into our scene and then pass it into our entities, or we keep it global. I don't know what the move is. We've got it global, so we can at least do it now. We can say if type is gecko, and if successful spellcast is true, if successful cast, if it's gecko, is that right? Wait, no, successful cast. Let's see. Oh my god, did it move? Why does it look... Oh my god. Get away from me. Dude, it's working. Oh my god, it's hard. Yes, get back. You fiend. Oh, yes. That is it. Okay, so I want to tweak a bit. We want to give it a higher initial velocity, and we'll see if that slows down. And we probably want to do this. Oh, get back. I think we want a even higher initial velocity and then a faster decrease. Let's try one. And then we want actually a faster decrease, which our decrease is where up here our decrease is set. So maybe a 0.8 decrease as well. Let's see. Damn it. There. Oh yeah, it really knocked them back. See, I think we want an even faster decrease. And then let's see how that looks. Dude, yes. Imagine him flickering red too when we hit him. Oh my god, it's so hard. There we go, yes. Now I think it's even... Gosh, I think I even want a faster initial velocity. I want him to be like really kind of smacked back by it. Oh, that was wrong, huh? That was wrong. We don't want the faster decrease. I mean, we did make it faster decrease. We want our DX to be a little bit of a faster speed. Let's see. Wow. Yeah, that was maybe too much. Wow. Yeah, that's actually pretty good. Wow. Oh my gosh, this is cool, you guys. This is awesome. So, okay, so what we need to do now, right now, what we're doing is we're always giving it a down and to the right dx. But what we need to do is give it a proper dx and dy based on its relation to us when we hit it. So like we can do, what is going on? Okay, so here we just need to do another check where we need to compare our x and y position, and if we're to the right of it, knock it to the left. If we're to the left of it, knock it right. If we're beneath it, knock it up. If it's above it, knock it down. So I think that's all we've got to do. Now we have referenced. Yeah, we can check. Now, I guess we can do it based on where it hits the spellcast entity, or we can do it where... Oh, let me think this. Because yeah, if we're checking, Lua does things at the top left index. So the top left of a spellcast entity would rarely knock something to the left, because that would mean the entity would have, or the bad guy would have to like walk. Yeah. For the most part, it's going to knock it to the right and down because it's rotating clockwise. So like the only time it wouldn't is if we hit it, well, okay, no, well. Yeah, let's do some testing here. Let's try to we need to compare our spellcast entity X position with our gecko's X and Y position, and then add the correct dx and dy. So let's check if our gecko's, and it would be a self.x, if our gecko is to the right of our, and you know what, I kind of feel like we can do this a little better. Like we can say because what I'm trying to avoid here is typing in sceneview.spellcastentities at i.x. So what I really want to do is just save, maybe we just say spell x gets the scene view dot spellcast entities at i.x, and then spell, you can't even spell x, scene view, why did I do that? Scene view spellcast entities at the ith index dot y. So now we can put these in local. And then now all we've got to do is say, hey, if our gecko's x is, I guess let's check left first. If our gecko's x is, I don't know why, but I want to do right first. If our gecko's to the right of our spell, so if our gecko is to the right of our spell by the time we collide, then we want to give it a positive dx. So we would say self.dx gets a positive 1.3. And then we can say otherwise we want a negative dx, because a negative dx would move us to the left, would move our gecko to the left, and we'd want to move it to the left if the gecko's position is smaller than the spell's position. So like if our gecko is in the bottom left, our spell hits it going clockwise from the right, it would move it to the left. Yeah, so give it a negative dx. Cool. And then we need to do our y, so we'll say if our gecko's y position is greater than the spell's Y position, that means the gecko is beneath the spell. That means we would give a positive dy. So we'd say self.dy gets that positive 1.3, and we can change this 1.3 into a variable, into a local variable here, but for right now, we're still tweaking the values. I mean, I guess it's... Let's just test it. Let's test it. We'll give it a negative dy if our gecko is above our spell, because that means we would collide and we would be knocked up. So I think that's right. So now let's go ahead and see if we did this right. So it knocked it down and to the right. Oh God. Damn it. It did move it to the left there. Yeah. Yeah. Oh, this is awesome. We knocked them right where we were walking. So I do think we need to shrink our hitbox a bit for this, because our flame is only like on average 10 pixels tall, and we're doing collision detection based on a 16 by 16 tile. So I do think we might need a specific collision command for this, and then it looks like we aren't. Well, let's see. Wow, this is awesome. This is awesome. I am very tempted. I'm very tempted to go crazy right now. So what we're gonna do is give ourselves more spellcast entities. So wherever and this is in our map, so if we go to our scene, however many spellcast entity counts we're given, let's see what it looks like with 3 fires around us, right? So, oh lordy. We crash on map, spellcast entities. So are we not passing in spellcast entity count for our map? We are. So why are you crashing? Map 68. I don't know if we're self.spellcast entity count, self.spellcast entity count gets our spellcast entities, which we are passing in as 3. So why? Maybe let's make sure every instantiation of our map is getting, oh God, spellcast entity count, which is up here. Huh. Why can't we do this anymore? Oh, well, we're doing this, which is wrong. We want to say that this gets our spellcast entity count, and maybe that'll fix it. Yes, 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 yes. 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 Okay, I'm about to get crazy, y'all. I'm about to get crazy. we want to put more geckos, right? We want to put more geckos. So let's go to where we're putting our geckos. Where is our gecko instantiation? Maybe we called it something like entity or enemy instantiations. Entity instantiations? No. Where is our... Is it not in our scene? Oh, it's in our map. Right? No? What the heck? It's right here in our map declarations. Okay, so let's give us 5 geckos. Okay, and then what we're gonna do is actually change the why is this hits gets true? We don't want that. Let me see. We'll put one gecko, and we'll see if the hit is still working. Yes. Okay, nice. Oh, this is awesome. Oh, I never even thought about that. You can kind of like pinball him if you get him inside your spells. Like he would hit you too, but you could like pinball him. Oh, that's cool. That's cool. So let's see. We give it 5 geckos, and then we want to multiply this or add it by like maybe a couple different pixels, right? So like I times maybe 3 pixels. So they have different X and Y positions so that we can see that they are not all on the same location. Let's see. We should have 5 geckos. Oh yeah, buddy. Oh yeah, buddy. Yes. See, they all got too messed up. Let's put oh. Yeah, we want this to be times maybe 5, maybe? Okay. Oh, this is awesome. This is really cool. Let's do... It's like, maybe not that much. Oh, hell yeah. Now they all have the same AI, which is match my X position first. Gosh, yeah, they get knocked. Max my X position first, so they all kind of line themselves up with my X. So we might want to change that so that the multiple entities don't all end up in one straight line like that. Wow, that is so cool. Because now that they're overlapping, they're all basically the same entity. Like, there's a little bit of difference, but wow. And what we could do is make it so that they can't get hit more than once in one, 1 second period or something. But we need to update their AI so that they alternate. Maybe some prioritize my Y position before they walk closer on the X, and some walk closer on the X first. So we'll need to do that. We'll say and maybe we give them a slightly different walk speed. Different entities, they come out of idle on a random time, but maybe they also have a different walking speed just by a slight variance. And then some of them prioritize my Y position, because look at, they track my X. So they don't walk closer until their X is equal to mine. So maybe some of them will prioritize my Y position, and some of them will prioritize my X, and then we need to adjust the hitbox for our spellcast entities so that it's a little more accurate, because if we take a look, we can take a look real quick here at our spellcast entity sprite. Oh, this isn't a good way to vary it. But if you imagine this being 16 pixels, you know, most of this space here isn't the bulk of what needs to collide. So we probably need to shrink our collision box so that it's only this main part of the flame here. Because right here, you know, we would detect a collision with a gecko if it collides right up here at the top of the 16, and that just doesn't look right in game. So we'll need to tweak that too. So we'll say shrink spellcast entity hitbox for enemy collisions. But this is really cool. This gets me excited. We finally got interactivity in our game between our spellcast and our enemies. So this is huge, y'all. And it'll look a lot better once they're not all lining up to be hit by me on the x-axis, you know? Oh, this is cool though. This is awesome. And you know what? Maybe the move is, well, maybe the move is 2 when we go to our declarations. Where is our map declarations? Do we not have it? Right here. Maybe what we do, so instead of in the center, we just give it a math.random, right? So we'll say that our x, we'll say our x gets a math.random of our virtual width minus maybe 2 times the tile size, so it doesn't go fully to the right of the screen. And then we get our Y position to be set to a virtual height, and then we make sure we close these. Let's see that. Okay, we need a comma, and we need a comma. Let's see it. Yeah, nice and random geckos now. Yes, man, that is cool. That's cool, man. I don't think the particles are that distracting. I mean, it's hard to say because we're on a very plain background. Like, there's very little happening on the grass here. Why are their Y not getting any values close to the bottom of the screen here? Their Y position should be higher than this. Oh. This is cool, guys. This is cool. Yeah, once we shrink those hitbox, give it a little bit more random AI going on, this will look a lot more interactive. Because they really do. Oh, and then once I knock them out, oh, they're coming out of freaking gang over here. Yeah, they really just gang up on the X. They line up. Yeah, why we're not... Maybe we have to do this screen height limit. They look like they're prioritizing the top half of the screen here. I don't know why. Okay, I mean, I don't know why they... I don't know why. This is awesome. This is awesome. Okay. This is great. Yeah, I agree. It doesn't look random. I agree. You know what? We aren't seeding our random. I don't think. I mean, yeah, we are. We are. Okay. Well, this is exactly what I wanted to get done today, and it was just over an hour, so that was perfect. We know what we've got to do. We're going to tidy up the AI a bit, randomize a couple of things, including walk speed, as well as the AI, and then this is really cool. Yeah, because I was thinking about making them walk diagonally so that they just walk in a straight line wherever we are. But just like how our character doesn't have diagonal sprites, I thought it was just going to be a bit too much to decide which direction sprite we actually render for them when they're going diagonal. I guess we could default it to like, if I don't know, we could default it to something, but we might end up doing that because when they line up like this, you can't really see how many there are, and if there's going to be 3 or more or 2 or more, then they're going to line up like this, and I don't want that in my game. We could add some other logic too that makes it so that they don't line up as close to one another, but we'll have to do some pondering on how we want to tackle that. Wow, this is really cool. This is awesome. So yeah, we might want to adjust the hitboxes to be a little more forgiving than the successful spellcast. No, yeah, we want it to be in the successful spellcast. It's just that sometimes, like the instant our flames leave the successful spellcast range, they haven't faded yet. So in that like first frame of leaving a successful spellcast, it looks like we should still hit them when it doesn't. So that's kind of what I was thinking of changing, but we really do want to do it based on the successful spellcast. So I think that means we would just make it fade a little bit faster, but we're happy with how it fades because we did some testing with it. But we're in a good position here. I didn't think we would get this done tonight in an hour, so that is very hopeful, very good. Okay, so let's check our get diff here and we'll see what we did. So we give ourselves a dx and dy for our entity class now, as well as a hit field. We update our dx and dy to decrease or increase over time so that we stop moving after we get hit. We assign the appropriate dx and dy based on which side of us or of the gecko that the spellcast entity hit, and then we're fleshing our self.hit to be false if we are no longer moving from a change in x and y. So like once we've stopped being manipulated by the knockback, we become unhit. And then we go ahead and we actually floor our particle system location to prevent that interpolation. We are giving ourselves 5 more entities, 3 more fire entities, and then we're also flooring our entities location on the X and Y for the render, not for the update, so that it looks a little smoother. So that was a good day, y'all. We're gonna do a git, add everything to the commit, add everything to the staging area, and commit with a message saying spellcast to enemy entity collision plus knockback. That's huge. That adds so much more oomph to our game. That is very cool. All right, so we did a git push. We didn't even do a git commit yesterday because we were doing music, but we got one today. I'm curious if anyone I know is streaming There's a guy who's doing Pico 8 coding who actually told me yesterday that Pico 8 is actually in Lua. So I thought that was really interesting. So I'm gonna go start a raid over to another Lua developer, and I know he'll appreciate it. I hope you guys have fun checking him out. Give him a follow if you want. But thanks for watching, and have a good night, everyone.